Great, thank you.
Hello,
Good
welcome
afternoon.
everybody. My name is Diana Lison and I'm the community manager for the Boston Healthcare Technology User Group. We are so thrilled and excited to have another in person, and we welcome the people that is with us at the Microsoft offices in Burlington, Massachusetts, and also to all of you that are connected to the streaming today in our diverse channels: YouTube, LinkedIn, Facebook. So, welcome everybody. And today, I want to introduce my friends, Paul Swider and Jean Philippe. Paul, good morning. Good afternoon,
Good
actually.
morning, good afternoon, good evening, whatever time it is where various folks are. And let me extend a warm welcome to our group. Again, we're here in person. We're making that transition, as many folks are, between the virtual events and in-person events. So this is our second one. I feel like we've got a couple of us worked out, and we're hoping by round 3 or 4, we'll sort of get the wheels going again. And so we have a small group with us here in person, but as you know, we stream to, I believe, 15 social channels now we're up to. So we have a huge streaming presence. And so again, welcome everybody who's live on the stream or catching this presentation afterwards. So just a quick little bit about our group. So we like to say that we're based here locally in Boston, but serving the global healthcare technology community. Our primary mission is really just to get more new folks and of all demographics into health technology. At first, I was going to say more young folks, but I think it's safe to say like we just want lots of new people, and really anybody with an interest in healthcare technology. And so the way that we do this is we try to get world-class speakers to do biweekly presentations and then stream those again globally. And so we are working on other projects as well, forming an advisory committee, building out our Discord community, and lots of other side projects to help us reach our mission. A quick mention of sponsors. So Microsoft has been gracious to sponsor us with space and advertising, listing on their technical communities, etc. And then Real Activity, locally based in Boston, is a sponsor for lunch and various other expenses. And we are actively looking for new both sponsors and speakers as we go into the next year. So feel free to ping us using the information here. So the home URL is bosshug.com. If you go to bosshug.com, you'll find our link tree and a ton of information on the group and various digital assets. And then we also have our Discord server, which is discord/healthcare. And so you can find our contact information there if you're interested in speaking or sponsoring or just learning more about the group. And so with that said, I'm really excited for today's presentation. I love talking about some of the newer technology. And, when I think about the technologies that are shaping the world right now, I think of three things. I think of AI, W3, and blockchain and all that good stuff, and then quantum. Quantum, of course, right? To me, those are sort of like the top three. When I'm looking like 10 years out, 5 years out, it just blows my mind where we might be with some of this technology. So for that reason, I'm really excited about this presentation today. I've got to see Jean present before, and it's my honor to introduce him here for the session. So without hesitation, Jean Bonnet, I hope I didn't butcher your name, will join us, and I'll switch over to you so you can share your screen. Thank you.
Hi, Paul. Hi, everyone. Hi, Diana. Good day, good afternoon, good evening to everyone in presential and virtually. It's an honor for me to be here with you. And thanks for the invitation to share something about quantum computing today. Let me share my screen again. That is, and thanks for that introduction, Paul, about the maybe the place that quantum computing has today in the world. I agree with you. AI, artificial intelligence, the Web3, blockchain, metaverse, virtual reality, and quantum computing maybe are the most disruptive technologies that we have today. Singularity University talk about the importance of that technologies today, and quantum computing is very important for the maybe for the next 10, 20 years, about to create more business models, solve other kind of challenges and problems for the humankind. Sorry for that misspell. It is not about financial market. It's for healthcare. My presentation today about quantum computing and a little bit with artificial intelligence. I'm Jan Bernier, CEO of Spin Quantum Tech. We are a startup located in the UK, focused on quantum computing. Well, you can scan the QR code there to get more information about us or find on the LinkedIn network. The agenda for today is three special topics. First, a brief about what is quantum computing. Second, think why quantum computing is important today. And finally, use cases in healthcare for quantum computing. That is the focus for me speak today, maybe in 25 minutes. So let's begin with that trouble. I always love to speak about quantum computing with this reflection and history about Steve Jobs on Apple, about maybe 2000 with the first iMac computers, transparent with colors, with a beauty design. That is from the Walter Isaacson book from Steve Jobs' leadership lessons, and is when behind leapfrog, and that is quantum computing today for most of the uses cases for the technology and for applications. The history says something that when Apple's launched the iMac in the 2000s, with the nice colors, nice designs, a beautiful presence with that computer, but with a normal CD-ROM device. And Hewlett Packard and other computers vendor launched the common computers with the black box and maybe the ugly designs, but using the CD writer and DVD. And some people say to Steve Jobs, well, the next model we can add again the DVD and the CD writer. But Steve Jobs says something that it is the time to make a leapfrog, and that was the born of the iTunes, the iPod, and the whole revolution about in content, in music, maybe video and other kind of contents in the world. And that kind of leapfrog, maybe exponentially, is about quantum computing, and that is the reflection that we I want to start today our presentation. Why is important to think in quantum computing today? Well, it's not a technology for the next 10 years or 20 years or even the next 5 years. The most important thing is maybe that stats in 2016, um, several research say that quantum computing will be a technology for the next 10 years or more. But the great news today is that quantum computing is a real technology today. We have small quantum computers today to start creating and solving small challenges, but we have the technology today, and not only one maybe quantum computing hardware. We have several alternatives for quantum computing. So, well, we can start today creating solutions with quantum computer in 2022, and maybe for the next 10 or 20 years, the evolution of the quantum computing will be a big or huge opportunity for develop new solutions, new algorithms to empower artificial intelligence, blockchain, virtual reality, metaverse, and other kind of technologies. And that is the importance in quantum computing today. All other of the technologies that you can see in that chart could be empowered using quantum computing to be more fastest or solve biggest problems today. But what is quantum computing? Maybe could be the first question that we need to solve. I like to explain quantum computing in two modes. Maybe for the view of the common people and for the business and the humankind, quantum computing is a new processing power, exponentially processing power compared to the classical computers, and is about the speed and opportunity to solve problems. Thinking that, for example, the most maybe biggest higher computers in the world, like the IBM Summit, for example, could take for a challenge 200 years to solve a task. For example, the factorials for RSA algorithms using prime numbers. A quantum computers with more than 2000 qubits could solve the same task in 1 minute or less. So that is the exponential speed of the quantum computer. 200 years to 1 minute. That is the importance. But what is different in quantum computers, and maybe the science version of the quantum computing, is because the first time we're using the quantum physics and the electrons and the spin of the electrons to understand the data, the status of the materia, and interpret that as processing power today. And that is exponential and more faster than the speed of light. So quantum computing maybe could be one of the first real applications of the quantum physics to create solutions in the humankind. When you think about quantum computing, maybe in that word cloud, you can find a lot of technologies and words that are important today in quantum computing. Not only artificial intelligence, we talk about new communications with a quantum internet, and we have the opportunity maybe in the next years to transfer amount of data in the same time. I mean, with no lag or time to transfer the information. Just thinking that quantum internet could move more than 1 terabyte in less than 1 second is maybe in the same time to move the information. Not only big data, cybersecurity, blockchains, new business model, encryption, there are a whole world of new applications and opportunities with quantum computing today. Let me um, fix my screen. That is, um, here is maybe a picture about the first quantum computers today that is using a superconductor technology. And that is important because maybe that picture 5 or 6 years ago is the test or the proof that quantum computers are real today. And the evolution of that is something like that. We have an IBM, an IonQ, the wave system are, for example, maybe another 8 or 10 hardware developers working on quantum computer today. And now the quantum computers are smaller, maybe portable. And I say maybe because we need a special move for that kind of computers, but we can move today, and they are growing in the process to democratize access to quantum computers around the world. And that is important because the ecosystem about quantum computing is developing today and is growing fast. You can find, for example, in hardware, a lot of vendors, a lot of opportunities working in different kinds of technologies and approaches for quantum computing. We have superconducting, trumpet ions, silicon, photonics, and we have another options today working in quantum hardware. But it's not only about the hardware. We have a software layer and a lot of companies working on software today in quantum computing. For example, we have the two companies that I live today, Spin Quantum Tech and NEQ, working with the Spin Quantum Tech cybersecurity and data encryption, and with NEQ artificial intelligence for quantum computing. And there are companies and applications using today quantum computing. I want to focus more in the maybe in the healthcare sector today. For example, AstraZeneca with the vaccines, Aztecs, drug and better material simulations are part of the importance of the quantum computing today. So the ecosystem with quantum computing is running now, is working, and is creating solutions for the humankind. We can find maybe, and the opportunity is huge, we can find a lot of knowledge areas to improve with quantum computing today. In this presentation, I want to focus in two areas: quantum chemistry and quantum simulation. First, quantum chemistry, because quantum computings enable us to create better materials, molecule simulations to understand and maybe diagnosis, medical image recognition, and create better molecules, better drugs, better food in the process. And quantum simulation is the option to understand that world, reducing the risk of the testing in the real world. That is maybe a risk that impact the healthcare, the medicine, the pharma world for the last years and maybe for the whole process of developing until today. If we think about the market, quantum computing, according to Deloitte, is an opportunity for this decade around $1 to $2 trillion about the developing technology today, and that is true because, for example, this is a research from Cureka in the United Kingdom. That is the investment today in quantum computing from the public sector around the world. So until today, we have $30 billion only in public sector thinking in quantum computing. So the opportunity is huge about that. Focusing on healthcare sector, the next information is a report from IBM. Well, that is important. Healthcare is generating a lot of data today from the trials, from the disease registries, all the electronic records that we have today, devices, the patient's information. I mean, the whole ecosystem around the healthcare is creating a lot of data. And not all of that data is analyzing or using today to empower decisions, to make better decisions, to prevent maybe disease and improve the life quality from the patients. And that is important because quantum computing enable us in a short time to create that kind of solutions. At least there are three main applications or use cases from quantum computing in the healthcare. And I want to talk about these three. First, diagnostic assistance. Sorry for my pronunciations. Diagnostic assistance, precision medicine, and improve the pricings from the healthcare coverage around the world. There are three big impacts that quantum computing can create today to empower our lives. If we think in diagnostic assistance, that is the merge between quantum computing and artificial intelligence, most focusing on computer vision. Today, we have the opportunity to analyze medical images of several sources, including videos, to understand or to diagnose and prevent disease and ills in the process. But it takes a lot of time to understand or create better models, better maybe clusterizations activities to identify the most important or most critical images. For example, in cancer research, the diagnostics using images and artificial intelligence is an important development today. Quantum computing enables us to go deeper into the image to improve the developing or the research about that image, but most important, to reduce the times and increase the size of the data sets that we use to create that kind of research. We can think that create an algorithm using artificial intelligence for cancer diagnosis is the same for everybody around the world. It's different. The DNA, the health, and maybe the molecular structure of people in Europe, in Latin America, in North America, in Africa, in Asia, and in every part of the world. We have several differences in how the diseases are developing and growing. Quantum computing enables us to create diagnostic totally personalized and customized for each patient, and having the opportunity to run models in a record time and create diagnosis totally personalized for each person in the process, and with the importance or with the impact, with the better price model to run that kind of artificial intelligence models today. For example, create a model using computer vision today that analyze, let's say, 1 million images could takes a lot of processing power, and that processing power in every cloud could be expensive. With quantum computing, we reduce the times to get access to train the model, to improve the model, to get access to the prediction of the model, and we can get that in less time with less pricing, totally customized to the patients. That is the second, or open the second option. And quantum computing allows us to create a precision medicine. And also, again, using machine learning techniques, we could improve the accuracy and reduce the risk in the predictions and create better solutions for the patients. Not all the treatments are the same for everybody, and not all people react with the same, maybe, um, with the same facts to the medicine. We can think in precision medicine to create better treatments, better focus to identify the differences of the diagnosis or the disease in every person, and create personally treatment for the process. Until before quantum computing, we use the umbrella approach, and using a research, we hope that basis on the statistics and the Gauss behavior, well, a lot of patients have the benefits of the treatment, but always we have more than 16% of the patients outside the normal behavior of the Gauss belt, sorry. Well, precision-based approach, we can use more factors to identify and map the health of the person, and create a specific and granular treatment and health status, and create a precise intervention for the patient. Also, the opportunity to create customized medicines to improve the health of that person. And that is important because we could go from the general treatment to a personalized treatment with medicines, with all the healthcare ecosystem, and that will impact the opportunity about pricing. With pricing, we can go down in the price for the healthcare coverage with a better focus on prevention and diagnose, but not prevention maybe 3 months before a disease start in a person. We can think in preventions in years, even from the born of the person, using quantum computing and understanding the developing of the DNA of the person. So quantum computing enable us with the new processing power to integrate more variables and impact the business model in healthcare, not only to improve the life of the person, the quality of life, also to improve the business model, reduce pricing, reduce time, and reduce risk in the process. And maybe that is the most important impact today with quantum computing focus on healthcare. I think we are in the time, so again, you can get more information about us and scan the QR code.
Hello again, it's me, Diana, and thank you so much, Jan, for your presentation. I think we have really enjoyed. Thanks to everybody that it's in the YouTube. We have many people connected right now. I encourage you to send any question if you have, and also if we do have questions in the auditorium, please let us know through the comments. um, yeah, I think it's really cool, Jan. Thanks for sharing this topic, and like we said at the beginning, we love to learn new uh, things and technologies, and this is something that we really love. Hi, Paul. Oh, is there any question in the auditorium so far? Just wanted to ask that real quick. Oh, sorry, we can't hear you. Are you on mute?
Yeah, sorry. I just wanted
All
to
right.
thank
Sorry, we
everybody.
can't hear you.
Can you hear me now?
Are you on mute? Yes.
Yes,
Oh, okay.
Yeah,
Uh,
sorry, I just wanted
All
to
right.
thank
Sorry, we
everybody.
can't
Hear you.
Yeah,
Can
great.
you
I
hear me
just
now?
wanted to
Are you
say
on mute?
thank you one last
Yes.
time. It was an
Yes.
amazing presentation,
Oh,
and I'm having
okay.
some sound
Yeah, sorry,
issues,
I just
so I'm
wanted
going to
to
cut out a
thank
little
everybody.
early.
Can hear you? Yeah,
But again,
great. I
John, that
just
was
wanted to say
amazing.
thank
Thank
you. Station. And I'm having some issues now a little early. All right. Thank you, Paul. Thanks again, everybody, for joining us to our session today. And so in the screen, we have our mailing list. Please join if you are not yet to get all the details of our next activities. And also, if you join too, if you visit our website, you can get the next meeting details. So let's keep in touch. Thank you so much, Jan, again. And until the next opportunity. Bye
thanks
bye.
to you, Diana. Bye bye. Have a nice day to everyone.
Have a good day.